Today we're going to learn how to easily calculate financial risk and performance metrics in Python using a package called Empirical. Empirical is super easy to use. All we have to do is we have to provide a list of returns, and then we can calculate metrics like Sharpe ratio, Colmar ratio. We can calculate alpha, beta, annual volatility, annual returns. And this video is going to be particularly interesting for those of you who are financial experts interested in a little bit of coding. You can, of course, also watch this if you're a technical expert interested in a little bit of finance. But at the end of the day, I'm going to explain the technical angle. This is a technical channel. I'm not a financial expert, so I'm going to show you mainly how to set everything up, how to use the package, what you can do with it. And I'm not going to talk too much about the different financial metrics, what they mean, how to interpret them. We're going to mainly focus on the technical part. So if you like this video, let me know by hitting a like button and subscribing. And now let us get right into it. Alright, now before we jump right into the coding, I would like to provide a little bit of context here so you understand the ecosystem. Empirical is a package that allows us to easily calculate financial risk and performance metrics. So all we have to do is we have to provide a series of returns. We can also provide a benchmark, and then we can calculate things like max drawdown, alpha, beta, Sharpe ratio, Sortino ratio, and so on. This is what Empirical is about, just getting the metrics themselves. Then in the same ecosystem from Quantopian, we have Zipline and we have Pyfolio. Both of these were covered on my channel already. You can check them out if you want to. Zipline is basically for event-driven backtesting, and Pyfolio is for portfolio and risk analysis. It allows you to easily create full reports with just a single line of code. And both these packages are built on top of Empirical. So Empirical is what drives these packages under the hood. Whenever they calculate metrics like here, they are basically using Empirical. Now, additional context, all these packages from Quantopian are no longer maintained. As you can see here, 6 years ago, 7 years ago, 8 years ago, 9 years ago, 10 years ago, these packages are not updated anymore. None of them are. However, there is a guy called Stefan Janssen, or whatever his name is pronounced, who basically forked all of these packages and still maintains them. This is the reason why we're actually going to take a look at Empirical Reloaded today and not Empirical, the package from Quantopian, the original package. We're going to take a look at Empirical Reloaded because this is still being maintained, at least somewhat. And the other two packages, again, if you want to check them out, I have tutorials on both of them. If you just want to generate entire reports easily without having to write a lot of code, you can just go directly with Pyfolio. If you want to do backtesting, you can go with Zipline. Empirical is for getting the raw financial metrics. Now, having said all this, let us move on to the environment setup. How do we get Empirical reloaded onto our system? How do we set up everything that we need to start working with it? For this, just open up the terminal on your system. On Windows, that's CMD or PowerShell. On Mac and Linux, that's the terminal. And then navigate to a directory that you want to be working in. In my case, I'm going to go to my tutorial directory here. And now you want to install the Python package to your installation. Now, I'm not going to show you how to install Python. I assume you already have Python on your system. And once you have Python on your system, you also have pip on your system that allows you to install packages. So pip or pip3 is the command, and then install, and then the package names. We are going to need Empirical-reloaded today. We're also going to use yFinance. I also have a crash course on yFinance. This is just what we use to get the data from the Yahoo Finance API. And in addition to that, we're also going to use JupyterLab. JupyterLab is just an interactive environment. This one is optional. You can also just run individual Python scripts. And the moment you have something solid, you probably want to have a Python script, not a notebook. But notebooks are good for learning stuff, for exploring stuff, for playing around with stuff. And I'm going to show you here in a second why. So that is the command you want to run, pip or pip3 install, and then these packages. In my case, I'm not going to do it like this, but this should not confuse you. You don't have to do what I'm doing here. I'm just going to do uv init and uv add these packages, same packages that I showed you, Empirical Reloaded, yFinance, and JupyterLab. The only reason I'm doing that is because I want to have this isolated in an environment here. If you don't understand what I'm doing, just ignore it. It doesn't concern you. Just use pip or pip3 install. Now, once you have this installed, you want to run Jupyter and then space lab. So not JupyterLab is one word, Jupyter space lab. And in my case, since I'm using UV, I have to say UV run JupyterLab. But for you, just JupyterLab if you're not using UV. And this will open up JupyterLab on your local host. In my case here, it opens it in my browser that's already running. And here now I have JupyterLab opened up. For those of you who don't know what JupyterLab is, it's an environment that allows us to work with interactive Python notebooks. So when I click on this button here, this will open a new interactive Python notebook, so IPYNB, this is what it stands for. I can save it, call it main.ipynb. And here the difference is I don't have just a single Python script that I run from top to bottom. I have individual cells that I can execute. So I can say a equals 10, then I can say print a, and then I can say a plus equals 10. So now a is 20. I can go back up, run this cell, then it's 20 here. I can run this cell multiple times. Then I can run this, and you can see every cell works on its own, but still they all are connected by the same kernel. They're all running in the same Python runtime, basically. So that is the idea of the notebook. Let us start working with empirical. And as I said, for empirical, we need to have a list of returns. And for that, we need to use the yfinance package to get these returns, or to get, first of all, the prices, and then calculate the returns from the Yahoo Finance API. So I'm going to say import yfinance as yf, and we're going to say prices is equal to yfinance or yf.download. Then we need to provide a ticker. In my case here, I'm going to go with AAPL, which is Apple. We can provide a start date, let's say 21st of January, and the end date is going to be 2024. 1st of January, that's the time frame I'm interested in. I'm going to also say progress equals false, just so we don't get the progress bar in the output. And when I do that now, we're going to see that this is going to pull a prices object. This gives me open, high, low, close for the Apple stock, but I'm only interested in close. I'm only interested in the closing prices. This is what I want to analyze. So now I get this series here with ticker, which is Apple, and then I get the date and the price of the respective day. Now, to get the returns from these prices, we need to calculate the percentage change per day. So I'm going to go and say returns is equal to prices, then percentage change. And then some days, of course, will have nothing because they have no change, or actually one might have it. So I'm going to say drop NA, drop the NaN values. And now if I take a look at returns, we're going to see one less row. I have 1,005 rows, not 1,006 rows. And then I have here the percentage change for the individual days. Now, if I'm interested in weekly or monthly returns, I can basically take that, copy it, paste it down below. I can say weekly returns is equal to prices, and then in between the percentage change and drop in A, I can resample. So I can say resample, and then the keyword for week is W, or the key character is W. And then I'm gonna go .last. And this basically now gives me the weekly returns. I can also get the monthly returns. So I can just say monthly returns. And in this case, I would have to provide ME. And then we can see for every month, at the end of the month, we get the returns, the monthly returns of the stock in percent. Or not in percent, but this number is percent. So that would be 11%, 6%, and so on. But we're going to just work with the ordinary return. So I'm going to remove this here. I'm going to show you how we can use empirical on basic returns. So let's say import empirical as EMP. And basically whatever you want to do now, you can just use autocomplete. You can say EMP dot, and then you can press tab here and you can see everything that you can do. For example, I can take the Sharpe ratio and I can calculate it based on the returns. I just have to pass returns and I get the Sharpe ratio given these returns, 0.89. Now, the Sharpe ratio is basically a ratio that also considers volatility. So it tells us how good the returns are compared to the volatility that we have had to endure. And it gives us a metric that also considers that. And basically a Sharpe ratio above 1 is considered to be good. Everything between 0 and 1 is quite weak. Everything below 0 is bad. At least that's what I think. So none of this, of course, is financial advice. Do your own research. I'm not a financial professional. I'm showing you how to use a package in Python. That's basically what this tutorial is about. So if I explain a ratio wrong, if I'm explaining some threshold wrong, don't judge me for that. I'm not a financial expert. But that is how you can get this ratio. You can also get another ratio like the Sortino ratio, and then you get 1.31. This is basically the same as Sharpe, but only considering downwards volatility. So we don't care about volatility when the volatility is pointing upwards. We're only caring about the bad volatility, and here we get a better ratio. The range I explained is basically the same. Above 1 is considered to be good. But also we can do some more basic stuff. We can say, for example, EMP cumulative returns based on returns, and then we get the returns up until this point. So here we have 163% starting from 2020 to 2023 29th of December. If we're only interested in the final number, we can also say, give me the cumulative returns final. That is only going to give me the total returns at the end of the period. That's just the last value here, obviously. Then I can also get the annual return, which is basically the return. If every year had that return for the last 4 years in this case, we would get to where we are right now. That's maybe not the best explanation, but basically the average yearly return is 27.46%. So if every year had this percentage, we would get to where we are, which is this percentage here, or 163%. We can do the same thing with volatility. We can say annual volatility based on returns, and then we get that 33.568%. And in case we want to group the returns, we can also do that. We can say emp.aggregate returns. I can provide the returns and then a string that says, for example, monthly, and then I will get for every month the returns aggregated for this specific month, the monthly return for 2020, January, February, and so on. And that's basically how you can work with this package, emp.something, all the different ratios, omega ratio, Kalmar ratio. You can also go with something like max drawdown. So what is basically the worst dip we had from a peak? So this essentially tells you from a certain peak down to the next valley, how big was the fall? And in this case, it was 31%, 31.42, which basically means that we had a peak and then the stock fell 31.42% before going back up or before going to the next peak. And we can also go with downside risk here if we want to, based on returns. Yeah. Again, I don't want to show you all the different functions. The idea is you have emp.something and you have all the different functions here that you can use for various ratios and metrics. Now, one thing that you might notice is that for some ratios, you're going to get an exception, an error. If you go, for example, with the Kalmar ratio and you try to do this on the returns, you will get a value error. And the reason for that is that we need to squeeze the prices. So we actually need to get rid of the multi-column index. I'm just going to add here at the top, prices is equal to yFinance download everything. And then at the end, dot squeeze like this. And as a result of that, we get it in a more convenient way without the multi-column index. And we can basically run through the entire thing again. Nothing changes. The only difference is now I can also calculate the Kalmar ratio. And the next thing I want to show you is how to work with a benchmark. How can we actually do stuff like calculating alpha and beta given a benchmark? For that, let's copy this line at the top, the prices. And now I'm going to call this, for the sake of simplicity here, strategy. Even though it's not backtesting here, we're going to call this the strategy of investing into Apple. And we're going to compare that to the benchmark, which is going to be the S&P 500, the SPY ETF here. So we're going to define these two. We're going to download the data for both. And then I'm going to calculate the returns. So strategy underscore returns is going to be equal to strategy and then percentage change again, then drop an A again. Then I can copy that. And we can also do the same thing for benchmark returns and benchmark percentage change and drop an A. Now, one important thing is we need to align these two. We need to make sure that the dates align just in case. For that, we're going to say strategy returns, benchmark returns is equal to strategy returns dot align with the benchmark returns. So we have the exact same dates. We're going to do join is equal to inner. We only keep the dates that both have in common. And now we have two return streams that are aligned that have the exact same dates. And with this now, we can just say emp.alpha beta, for example. We can pass the strategy returns, the benchmark returns, and as a result of that, we get the alpha and the beta. So this tells us how much it moves with the market or how volatile it moves compared to the market. In this case, it goes into the same direction as the S&P 500, but in a more volatile way. And here is the excess return that we get compared to the benchmark. And in this case, I think 0 to 0.15 is considered okay or good. Everything above that is even better. But that is now alpha and beta with a benchmark. If I may for a second, I would like to plug myself in as the sponsor of my own video. If you go to my website, neural9.com, you will find a tab services and a tab tutoring. Here you can hire me for all sorts of stuff like data science, machine learning, web development. If you need help with something in a project, Here you can book me for one-on-one tutoring if you want me to teach you personally something that you don't understand. If you like my teaching style, on both pages at the bottom, you can contact me via mail and also via LinkedIn. Just wanted to let you know about this. And basically, there's not too much more that I can show you here. You just have to work with the functions that you have here. But I want to show you maybe a more practical thing. It's not really about the package, just a use case. You can define functions that can calculate multiple metrics at once for you. So we can say, for example, my metrics calculation. Of course, you can find a better name for your function. You just pass returns here, and as a result, you get a data frame with some metrics in there. So we can say import pandas as PD. Pandas is already going to be installed because we're using yFinance and Empirical. And here now I can just do the same thing that we did, or actually we can make it even more convenient. We can just say, give me the ticker, and then I can say prices is equal to, and we're going to use this download line. So I'm gonna just remove the strategy from here. I'm gonna say YF download. I'm gonna replace AAPL by ticker. Theoretically, we can also provide start and end date. Let's actually do that. Let's say start is equal to, by default, 2020 0101, but we can also overwrite this. End, same thing, 2024 0101. Then I can just overwrite this with end and start. Then I can say returns is equal to prices, percentage change, and then just drop NA. And now we can just define whatever we're interested in. So I can say metrics is equal to pandas data frame. And in here now I can provide a dictionary with the column names. So metric, for example, is going to be a list, and the value is also going to be a list. And essentially I can just provide the metric name and the value name, and we can add whatever we want. For example, I can say annual return. I can say annual volatility. I can say Sharpe ratio. I can say Sortino ratio, and I can say max drawdown. And then I can just provide the respective values here. So just the same thing, annual return with EMP on returns, then a comma, then I can copy paste that and change this to annual volatility. I can change this to Sharpe ratio. I can change this to Sortino ratio. I can change this to max drawdown. And that's basically it. Then I can just return my metrics. This is my function. And now I can say my metrics calculation NVIDIA. And I get my values. Or I can say my metrics calculation Tesla. And I get my values. And of course, I can also make decisions based on that. I can program algorithms that react to these metrics. I can also screen for certain assets that have certain ratios. You can do whatever you want with that, but this package offers you the easy way to calculate all of these metrics. Again, all you have to do is emp.autocompletion, and you can see everything that you can do with this package. And if you want a simple way, if you just want to have a portfolio analysis without coding anything, check out my video about Pifolio. So that's it for this video today. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Also, in case you're interested, on my website, you will find a services tab and a tutoring tab. There you can contact me if you need help with a project, if you need a freelancer, a consultant. At the bottom of both pages, you can find a LinkedIn link and also my email. Feel free to contact me. Besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.